Good morning, students. So,
Good morning.
did
Good morning.
you, good morning. Did you read the topics?
Yes, ma'am.
Hmm?
Yes, ma'am. I read only once.
Look, students, in this computer organization subject, we are trying to understand how a computer system is made up of and what are the components, how they are interconnected, and how they interact, and what are their functions, and uh, how instructions are executed, what are the instructions of a computer. So in it is not very easy to imagine that, because it is a complex structure. What I suggest you all is, please go through once so that it becomes easy for you all to uh, grasp the concepts. So, do you want me to summarize or revise the previous topic, or I can continue from today's topic and then discuss that on Saturday?
Once revise, ma'am.
Revise?
Yeah, ma'am.
Revise from which topic? Tell me from which topic you want me to revise.
Time control, ma'am.
Hmm? Which one? Which one? Timing and control. Okay.
Ma'am.
Yes, yes.
Instruction cycle is understand, ma'am. Timing control structure. Can you explain again?
Okay. In chapter 4 is clear. Everything in chapter 4. Once go through chapter 4 also. In chapter 5 we studied about, we have started with instruction codes, and this one we have gone through memory unit and instruction format. Is this clear?
Yeah, ma'am. Clear.
Direct, indirect address,
Indirect address, direct address.
clear?
Hmm.
Okay, this list of registers
Okay, ma'am.
and common bus system.
Common bus system.
This question is for everyone. Common bus system is not clear?
Can you explain again, ma'am?
Yes. Uh, Common bus system means, suppose uh, did you see in one restaurant, uh, there is like platform kind of structure placed on all the tables from the kitchen, and then what happens is they place the food, ordered items on that, and then that ordered item will travel on that track, and then go through various tables. Did you see this? Anyone? No?
Yes, ma'am.
You saw, na?
Yes,
So
ma'am.
that track,
Yeah, ma'am.
there covers so many different tables, right? Multiple tables are covered, no, using that. You have individual tables. Suppose if there are 10 tables, that track is created in such a manner that it covers all the tables, all 10 tables. Like that, in these are individual units in a computer system. You have a memory unit, you have these registers in a processor, so they must be connected. Otherwise, how will they communicate? Suppose uh, you want to go to your friend's house. Suppose these all are houses. This a particular road will connect them, and also a communication bus or a transportation vehicle, a car or a bicycle or something. What you can do, if suppose on one road, from one end to another end, um, house number 1 wants to send some item to house number 10. Suppose there are 10 houses on that lane. Then suppose there is a robot. So what robot will do, will take an item from house number 1 and travel through the lane and reaches house number 10 and give it to house number 10. So if suppose house number 8 next wants to send something to house number 5, then again robot take that, and so it is like they are communicating, they are sending some items, some messages, something through that mechanism. Same thing here. What happens here? Here in this structure, this is a bus structure is connecting all registers,
Connecting
all
registers with
memory.
the logic unit.
Yes, suppose if AR wants to send something to memory, then because AR is directly connected here, it can send the address to memory. Now suppose PC wants to send something to DR. So what PC will do? Put out the message on here on the bus. Then this message will travel like this. Where how it will travel? In this path it travels until it reaches DR input line. So from here it goes into DR. Okay. If AC wants to send something to AR, then what happens? AC will put the data here and it travels and travels and reaches this input path of AR. Now did you understand this bus?
Yes, ma'am, little bit.
Hmm? Okay. Uh,
We didn't understand how the memory travels and all.
you did not understand how the memory travels and all? Okay. What happens is there are here only the timing and control structure will come into picture. What happens is when PC wants to send something to AR, so what PC will do? PC will specify that it is sending the data to AR. Then here LD is there, no? LD, INR, CLR, all these. To this LD, timing signal is timing input is connected, timing output is connected as input to these registers. So when PC tells that I want to transfer some data to AR, then that timing signal will send out as 1 to AR. This load will become active. This load will become active, and when this PC will send out the data, then it travels, and here when it reaches AR, because its load is active, it is entered in, it is given to the AR.
Hello?
How? Now next tell me.
Uh,
Yeah, tell me. I'll try to make you all
Sorry.
understand. Any other doubts in this bus structure? Are there Jagdish, Naresh, Yasmin, Shravani, Amarendra? All students and Prem also. All of you are clear or not?
Yes, ma'am. Go ahead.
Okay, after bus structure, computer instructions, three types of computer instructions.
Ma'am, uh,
Hmm.
ma'am, 2 minutes before I can't hear to your voice, ma'am.
Okay, what is your doubt? Tell me.
There is no doubt, ma'am, but I can't hear your voice, ma'am. That's the problem.
No, okay, okay. From which point you did not hear, and what do you want me to explain again? You tell me, I will explain again.
Hello,
Yes. Hello.
Hel-
Is
hello,
Jagdish? Who is talking now? Jagdish. Okay, Naresh. Naresh. Students, I'm
Yes,
going ahead. Computer instructions are clear. Instruction set completeness, timing and control. You want me to explain again? So timing and control, if you look at here, there is a sequence counter. This sequence counter will generate timing signals. When it generates timing signal, whenever a new instruction has to be executed, a timing signal is generated. And this timing signal, it starts with T0 and ends with T15. So when SC means sequence counter generates 0000, then T0 will be activated. What happens at time T0? As we know, when an instruction cycle is executed at time T0, you are transferring the contents of PC into AR. This is a transfer statement. You are transferring PC into AR at T0. And at T1, what happens at T1? See, you try to understand this control unit with respect to instruction cycle execution. Then you will understand more clearly. So when it generates T0, transfer of PC into AR takes place. When it generates T1, some other operation takes place. When it generates to T2, some other operation takes place. So this is our instruction register. In this instruction register, we have address part, we have operation code, and we have mode bit. So this timing from sequence counter and then this instruction from instruction register, both are feeded as input to control logic gates. These control logic gates will take these timing signals and apply these timing signals as inputs to apply these timing signals as inputs to uh, when you are transferring when you are suppose if, when I said that a bus takes the value of PC and uh, activate the timing load signal of AR, because at that time, because that timing signal T naught is connected to load input of AR. That's why that will get activated, and then whatever you are sending on through whatever you are sending from PC will be given as input to AR. And then at time T1, if you look at here, time T1, what we are doing, IR M of AR you are transferring into IR, and then you are incrementing the PC value. So at time T1, all these timing signals are connected to that bus structure. So at time T1, what happens is IR load will be activated because of this T1. IR load input will get activated, and M of AR means memory will put out the memory contents on the bus, and then because IR load input is activated, it is transferred into IR. This T1 is given as uh, timing signal for IR, whereas T naught is given as timing signal for AR. T2 is given as timing signal for AR, and for decoder, decoder will perform decoding operation. Here decoder is there. Here you have a decoder. This part, this decoder. This will get timing signal T2. When T2 is given as because decoder has select input lines, that in that line will be connected to the uh, timing signals. So in this manner, this control unit, this is a control unit. Control unit will generate control outputs. What are the control outputs? Control outputs are nothing but the timing signals. And how timing signals are generated? Based on what is to be done at which time. Suppose if you take college timetable example, then what happens is at 9 o'clock there is somebody's class. So when bell rings at 9 o'clock, who will get activated in the staff room? Suppose 10 staff members are seated. At 9 o'clock when the first bell rings, out of 10 teachers, only one teacher will get activated. So that timing signal is generated, and then a teacher will get activated and will go to the class. And students, because the students knows that at 9 o'clock, suppose math class is there, students will take out math notes and wait for the teacher, and then teacher arrives and teach math concepts, and then bell rings at 10 o'clock. This is like control unit signals. And when bell rings at 10 o'clock, then so many other operation takes place. What are the operations? The teacher who is in the class takes attendance and stops the class, and students put down that notebook and then take out another, suppose English class is there, take out English notes, and then English teacher will get activated in the staff room, and then English teacher will get up and go to the class. So whenever timing signal is generated, many functions will take place, and this diagram shows how control unit will generate the timing signal. How the attender will give the bell, he will look into the watch. He will look into his watch, and then he knows how to see the time, and then when 1 hour passed by, then he gives the bell. So then like that control unit will give the timing signal, that is like bell, and then whoever is related to that bell, because others will know that what they have to do at that time, so they will perform that function. That is all about this control unit. I hope it is clear now. And instruction cycle is clear, you said. Next, this flowchart is clear. And these are register reference instructions. Yesterday we looked at. And these are memory reference instructions. This is nothing but memory reference instructions you are putting in the form of flowchart. If you learn this table, it is sufficient to do everything that follows it. All the subsequent concepts, are related only to this table. If you understand this table, then you can do all this. If you have any doubts in that table, please let me know. Okay, today's topic is we have learned that there are three types of instruction: memory reference instructions, register reference instructions, and input output instructions. Memory reference instructions are AND, add, LDA, STA, BSA, BUN, IZ. There are 7. And register reference instructions are CMA, CME, and then CIL, those and so on are register reference instructions. Coming to input output instructions, we have 6 instructions. Before delving deeper into the instructions of I/O, let us first understand how a computer accepts the input and displays the output. So for that you need to understand I/O configuration. In this, what happens is, uh, if you remember from the list of registers, we have 2 registers which are related to I/O, INP and OUT. INPR means INP input. INP is input, R is register, OUT is output, and R is register. Input register and output register. So in this, what happens is, in this configuration, in this configuration, we have accumulator. This is a processor register. We have input flag FGI. This FGI stands for input flag. It is a flip-flop. FGO is a output flag. It is also a flip-flop. Means it can store only one bit, single bit of information. And then the input device is keyboard. Then the output device is a printer. Then user will type or feed some data through input device, and input device is connected to input register through an interface. Through an interface, input device means keyboard is connected to this register. It is like some kind of connecting mechanism which will connect keyboard and input register. So when you press A or when you hit any other key, T, H, then what happens? It goes through interface into the input register. It is stored in the input register. And then this flag is set to 1. Why this flag is set to 1? To indicate that there is some data available in the input register. Whenever this flag is set, then accumulator will read the data from input register. Because accumulator, if you are performing an operation, addition operation using Java program, so the program has prompted you to enter a number. Then the program waits until you enter a number. Suppose you enter 3. When you enter 3, what happens? 3 should go to accumulator. Why it should go to accumulator? Because you have to perform arithmetic operation, and all the operations are performed within processor, and the most important processor register is accumulator, and accumulator holds the operands. So that 3 has to go to accumulator, and then some operation further can be performed on it. This is about this input part. Now the output part. Consider that you enter 3 and 2. You know that one operand will be in accumulator, one operand may be in another register, or in memory. It depends on the type of machine. So there are two operands which you have entered, and you have to perform addition operation. Means processor has to perform. After performing that operation, processor has to display the result onto the monitor. So or a printer, suppose if you are printing it, here you can put monitor also, it doesn't matter, any output device. So that the sum of 3 and 2 is 5 has to be displayed, and the result 5 is in accumulator. So what happens is accumulator put out that in the output register. That 5 will move from accumulator into output register, and then this flag is set to 1 to indicate that there is a data available in output register. Then what happens from this output register? It goes through receiver interface. What is this interface? This one will connect output device with the output register. So it goes to goes through interface to the printer or monitor or whatever output device it is. In this manner, input output um, operations takes place. Operation in the sense the reading of the data from the input device and displaying of the data onto the output device. Is this clear? If you have a doubt, please ask. Okay, so next, these are the 6 IO instructions. What are the IO instructions? Can anyone tell me what is D783 means? Yesterday I explained you this. If anyone can tell me, then it means that some students at least are understanding. Who can tell me what does D7IT3 means? Somebody has to tell me, otherwise I won't go ahead. What is the essence of just um, passively attending the class? You have to become active. Just listening is a passive mode of learning.
Ma'am, D is decoder, T is time
T7 is
signal where that time that particular T3 signal is
these
T3,
are
ma'am. T3 is signal at which time that signal has passed through the time. D7 is
T3.
the
T,
decoder.
you're right. D7 is decoder. T is that signal. Which signal is it, and why T3 we are putting here?
At the time of three only we can do decoding, ma'am. At the time two and one, we can do fetching the
At T naught we can fetch it, or T1 we
functions that
fetch. Yeah, you are very close to the answer. Please tell me. Nine students are there. Jagdish, Mahesh, Kirti, Naresh, Prem, Shravani,
at the time of
Srinivas. Hmm. At the time of?
ma'am,
Tell me, at which time?
ma'am,
Hello? Are you not able are you not able to hear me?
at the time of T3 only we can decoding the in
At time T3, we are decoding. What are we decoding? Okay, I will open up this. Okay, look into this and tell me. Look into this and tell me what is the meaning of D7IT3. Prem, Naresh,
Yes, ma'am.
tell me what is D7IT3?
Sorry.
What is D7IT3? Please elaborate.
Hello?
Hello, Naresh, are you not able to hear me? Are you able to hear me?
Ma'am, what's happening, ma'am? Sometimes only video is available. We can't hear your voice. Somebody is trying to mute you off, or is it happening automatically?
Somebody is muting me.
How could that happen? Why would someone do that, ma'am?
Who is muting my audio? Okay, students, it's not muted. Are you able to hear me?
Now we can hear you, ma'am. Until a while ago, we couldn't hear you. We were
Really?
just able to see what you were doing.
Oh, okay, okay. Okay, now you tell me, Naresh, what does D7IT3 means? Do you know it or not? Hello?
Hello?
Yes, students, are you able to hear me?
Yes, ma'am. Now we can hear you.
Hmm. So we are studying input output instructions. So I asked you all, anyone to explain D7IT3, but I did not get the answer. So I will only tell you the answer. These IO operations are performed when the instruction register will have 111 at opcode level, opcode section, and 15 bit, that is the mode bit, is also 1. When you get 111 in opcode, then D7 will be equal to 1. So D7 is 1, that decoded value, and I is the mode bit. I is also 1, and then T3 means at timing signal 3, IO operation will be executed. This means that, and you are assigning this term to P, a symbol P, and I means this is bit I, bi. You have b6, b7, b8, b9, b10, b11. Um, if you remember, the address part of the instruction register contains address in memory reference instructions, contains operation codes in RR and IO instructions. So these B's denote that, the address part. If it is 6, it is a particular IO instruction. If it is 7, something else like that. So at P, sequence counter is cleared. Sequence counter is cleared at P. P means when D7 is equal to 1 and I is equal to 1 and T3 is the timing signal. INP is the first IO instruction. Second IO instruction is OUT. third IO instruction is SKI, fourth IO instruction is SKO, and ION and IOF. INP means input character, OUT means output character, SKI means skip on input flag, SKO means skip on output flag, ION means interrupt enable on, IOF means interrupt enable off. So uh, just we understood the input output configuration. So if you look at INP instruction, what does it do? It copies input register contents, it transfers the content of input register into accumulator. And accumulator is a 16-bit register. So you have to copy this uh, information which is of 1 byte, which is from 0 to 7. So from the position 0 to 7 of accumulator, you are transferring the input register contents. And then you set you clear the input flag, you clear, and then you output the accumulator contents, you transfer into output register and clear the flag. And then if input flag is equal to 1, then we are incrementing the program counter. If output flag is 1, then we are incrementing the program counter. And if in interrupt enable on is the instruction, then IEN we set to 1. And if um, I if IOF is 0, then if IOF is the instruction, then IEN, that is also a flip flop. It contains a single bit. It is cleared. It is cleared. Means interrupt is off. Here interrupt is on. We have to understand what is an interrupt. To understand what is an interrupt, we have to look at interrupt cycle. Like we have instruction cycle, we also have interrupt cycle. In the instruction cycle, an instruction is executed by following the 4 phases: fetch, decode, read, and execute. When an interrupt cycle executes, then what happens we have to understand here. There is a flip-flop again R. This R will determine whether it is interrupt cycle or instruction cycle. If R is 1, it is interrupt cycle. If R is 0, it is instruction cycle. What happens is, when a computer is executing an instruction, first it performs fetch and decode, and then it is executing. During the execution of an instruction, if IEN flag is 0, it checks. This is decision box. This is a decision box. So if IEN is 0, then you go to the beginning. If IEN is 1, then you check um, whether input flag is on. If input flag is on, it is like equal to 1. If input flag is off, it is equal to 0. FGO means output flag. If output flag is 1, it is equal to, means what happened here is, If suppose some data is available um, in the input register, then input flag is set is 1. If it is equal to 1, then you have to process interrupt cycle. If it is equal to 0, you are checking if any output flag is 1. If output flag is 1, it means that you have to perform interrupt cycle. And then you set flag R to 1. Whenever you set flag R to 1, then what happens? Interrupt cycle is executed. If flag R is 0, means if FGO, FGI and FGO is 0, then it means that there is no interrupt. Okay, let me explain you this with an example. Interrupt means, suppose in a classroom environment, suppose a teacher is explaining a concept and you get a doubt. Then what you do? You raise your hand. Okay, you raise your hand. When you raise your hand, what teacher will understand? That the student is having a doubt. And then what teacher will do? Teacher will stop the uh, discussion of the current topic and go and address the doubt of a student. Mm, while teacher is writing on the board, what teacher will do? Teacher will look behind to see if any student is getting a doubt. If a student gets the doubt, teacher will address it. Otherwise, teacher will continue explaining the concept. So here processor is a teacher and input output devices are students who can raise interrupt. IO devices can raise the interrupt. So suppose suppose a CPU is performing some operation, and during that operation user enters a value in the keyboard, 3 or 4 or something. Then what processor has to do? Take the value from the keyboard through the keyboard interface and through from input register into the accumulator. To do that, processor has to execute interrupt cycle. Instruction cycle is a cycle in which processor will execute user programs. Interrupt cycle is a cycle in which processor will address IO requests. So here processor has fetched and decoded the instruction, and during execution processor will keep checking this flag. What is this flag? Interrupt enable. Interrupt enable, if it is interrupt enable is off, then it will continue instruction cycle. If it is on, then it will check whether there is any uh, any request from any input or output device. If suppose there is any request, then it has to address that. To address that, what it does is it it set the flag R to 1. Why it set the flag R to 1? So that the next time it is executing the interrupt cycle and not the instruction cycle. Um, please, all of you, those who are having doubts in this, can ask. Are you getting the concept? What we are studying? Why are we studying? Naresh? Naresh? Yasmin? Naresh, hello. Okay, this is about interrupt cycle. And then what happens? This is the demonstration of interrupt cycle. What happens in during interrupt cycle is, uh, suppose the processor is currently executing 255 instruction at 255 and interrupt occurs. So what it has to do, it has to jump to uh, this 1120 address. So what it does is, it stores the address of the next instruction where it has to resume 256 at location number 0. Look at here, it stores the address 256 at location number 0, and then it executes the instruction stored in location number 1. What is there in 1? 0 means direct address, BUN means branch unconditionally, 1120 means where it has to jump, the address where it has to jump. So it is jumping to 1120, it executes IO program, and then here 1 means indirect address, BUN means branch unconditionally, 0 means 0th. Now first you have to go to 0 is the address. First you have to go to 0th address. Next take the address where you have to resume the execution, that is 256 from 0th location, and jump to 256. This is how uh, interrupt cycle uh, is executed by executing the IO program. Okay, that's it. Um, Students, any doubts?
Ma'am, are you able to hear me?
Yes, I am able to hear you.
Yes, ma'am. Couple of times, well, many times, your audio is being muted, ma'am. Not by someone, not someone is doing it intentionally, but it's happening automatically. Uh, it might be the problem of Skype, ma'am. Skype's internal problem. Maybe it has large user base, which
Now,
is
no?
affecting it.
Mm.
And coincidentally, when I'm unable to hear you, when I'm switching on my microphone to on, then I'm able to hear you, ma'am.
Mm-hmm. Okay, Naresh, might be there is some problem. All of you, please study chapter number 4 and 5, and then we will again discuss if you have any doubts. Now I will end the class. I will not start that 7.1 today. Tomorrow we will see. Please go through that 7.1 again and come to class tomorrow at 11 o'clock. Okay?
Okay, ma'am.
Bye.
Bye, ma'am.